Now let us talk in detail about algorithm analysis. Once you design different algorithm to solve a problem, you need to find out which algorithm is better or which one is efficient. So we calculate the amount of resource an algorithm takes, but we mostly focus on the running time. Given an input size n, we want to find out the running time of an algorithm, or we want to analyze the algorithm, or on the basis of input size. So to analyze an algorithm, we have got two methods or two tools or approach. One is random access machine (RAM), and the other is the asymptotic analysis. Here we calculate the best, worst, and average case complexity of an algorithm. I'll cover this on the later lecture. Here I'll be talking about random access machine. So what is random access machine, or why we need a random access machine? Let us say we want to compare an algorithm A and algorithm B. So if I run an algorithm A on a machine with faster processor and algorithm B on a machine with slower processor, then I cannot compare these algorithms, because this is running on the faster machine and this is running on the slower machine. So we need a standard machine or a generic machine in which we can implement these both algorithms and compare those algorithms. So this standard machine or a generic machine is called a random access machine. A random access machine basically consists of 5 components. These components are input tape, program counter, RAM program, there is a memory, and there is a output tape. If you see the architecture, it resembles the von Neumann architecture. That is, there is a CPU in the middle with a memory, and there is some input, and that input is processed and it produces some output. So what is an input tape? Basically, you know what is an input tape is. There are a tape consists of some square boxes and there are some values. And the RAM program basically it maps the values from the input tape to the values in the output tape. What is the program counter? Basically, it stores the instruction that is to be executed next. And the memory consists of registers, and the first register is called accumulator. So this is the architecture of a RAM. So how can we analyze the algorithm in RAM model? That is the question. So to analyze an algorithm in the RAM model, we implement the algorithm here in the RAM model. Then we count the number of primitive operations that an algorithm takes. So how we calculate the primitive operations? Basically, what are the primitive operations? The primitive operations are assigning values to the variables. That is, within the algorithm, we need to assign some values to the variables. Or there may be some arithmetic operations such as addition, multiplication, division in the algorithm, and those are primitive operations. Or there may be a call to the functions, or there may be a return from the functions in the algorithm, that are also the primitive operations. And there may be we need to compare some values in the algorithm, within the algorithm. These are also primitive operations. And but if there are loops in the algorithm, or there are some subroutines, then these are not primitive operations. But within the loops, there may be many primitive operations or one primitive operations. So we basically count these primitive operations in the algorithms to find the running time of an algorithm. So and the other thing is that these primitive operations take constant time. That is, each primitive operation takes some constant time to execute. Uh, so we'll take an example and find out the running time of an algorithm using the random access machine. Let us take an example. We have got algorithm 1, and there are some steps in the algorithm. Let's say integer a is equal to 0, a plus plus, and integer b is equal to a plus 5. Now, how do we analyze this algorithm using a RAM model? Now, to analyze this algorithm, we count the number of primitive operations here, or we count the number of steps of primitive operations that are in the algorithm. Now, what are the primitive operations over here? Let us count the number of primitive operations. We define our integer a, then we assign some value to a. Therefore, this is one primitive operation. Now we increment the value of a. Therefore, this is another one primitive operation. And then what we do? We define our integer b and we assign some value to b, or this is an arithmetic operation. Therefore, this is also one primitive operation. Now, finally, what we do is we define the running time of an algorithm using our mathematical functions of input. That is, we define some function of input, and that is input as we now what we do is we sum up all the primitive operations in the algorithm now, and each primitive operations take a constant time. You should know that. This will be clear when we will be doing more examples. But right now you should know that there are 1 plus 1 plus 1 primitive operations. Hence we say that the complexity is O1. Now this may be a bit of unusual term here, but this will be clear after doing some examples. So why it is O1? Whenever there are no variables or there are only constant terms, then we write the complexity of an algorithm as O1. Now we'll do a complete example later on, then I'll explain over there. Now let's say we have got algorithm 2 that have some loop. Let us say it have got for loop for I is equal to 1, I is less than equal to n, and I plus plus, and print I now. So what are the number of primitive operations in the for loop? Now if you know the syntax of for loop, then you should know that first we initialize some value to I. Therefore this is one primitive operation. We count this as 1. Now here I starts from 1 and it is less than equal to n, that is we check some condition over here, and checking is also a primitive operations. But how many times do we check here? Now let us say that if we take n is equal to 4, then first we check when I is 1, then we check when I is 2, then we check when I is 3, then we check when I is 4. When I is 1, 2, 3 and 4, it goes on the body of the loop is executed, but once again we have to check for I is equal to 5. Then only the loop terminates. Hence we check for 5 times. Therefore when n is 4, but when n is n, then we check for how many times? N plus 1 time. Because I starts from 1 and I is less than equal to n. Then how many times do we increment the value of I? Incrementation is also a primitive operation. We basically increment the value. First I is 1, then we increment, then we increment, then we increment, then again we increment. Therefore we increment for 1, 2, 3, 4 times when n is 4. Then when n is n, we increment for n time. Right? Now, how many times does the primitive operations inside the loop executes? It executes for how many times? N time. Right? Now, suppose we have got another operation inside the loop. Then let's say I is equal to I plus 1. Then how many times this operation executes? It executes n time. Right? So how do we write the complexity or running time of this for loop? We define mathematical functions of time of input, that is n. Then we sum up all the primitive operation, that is for this one is it 1, for this one it is plus n plus 1, then for this one it is plus n, and for this one it is plus n and plus n. So these are the number of primitive operations over in the loop. Now So what do we write here, or what is the complexity of the algorithm? Then basically it is 2 plus 1, 2, 3, 4, 4n, right? Now what we do is we find the dominating term in the function. Which one is the dominating term? 2 is a constant, 4 is a constant, but n is a dominating term. Therefore we ignore all the constant and we write O n. So the complexity of this for loop is O n. This is how we analyze using a RAM model for loop. Now let us take algorithm 3. Now let us take the algorithm 3 as while loop, that is first we initialize I is equal to 0, then while I is less than n, then what we do? We do print n I plus, or sorry, print I or n, then what we do? I plus. Now what are the number of primitive operations here? Here I is equal to 1 means this is one primitive operation. Now here we start from 0, right? We start from 0 and and we compare how many times when I is from 0 to less than n. Therefore if n is, let's say, 3, then we start from 0, right? Then we check for 1, again we check for 2. Now we check for 1, 2 and 3 times, plus again we need to check for what? We need to check for 3, so that whether to go inside the loop or to terminate from the loop. Therefore we make how many comparison? N plus 1 comparison, because I starts from 0 and I is less than n. Suppose if I is less than equal to or less than equal to n, then how many times do we compare? We compare for n plus 2 times, right? Because we go for 3 and again we need to check for 4. But we have got I is less than n, then we compare for n plus 1 time. Now how many times does the body of the loop execute, or the primitive operations inside the body of the loop execute? It executes for n time, and this also executes for n time. Now how do we analyze? We write a mathematical function as Tn, then we write 1 plus n plus 1 plus n plus n. This is 2 plus 3 n, right? Now finally we write what is the dominating term over here? N is dominating term, and we ignore the constant, therefore it is O n. Now what is O n? It will be clear on further lecture. Just remember that how we count the primitive operations here. Now let us say we have got a conditional statement, algorithm 4. Now let us say we have got if, then condition, and then we have got some statements, and else, then statement. Now, and here either this part of the statement is executed or this part of the statement is executed. Here we can have for loop, while loop, or anything, and here also we can have any primitive operations or for loop and while loop. So what we basically do is, if suppose we get here some dominating term as O n, and here we get some dominating term as O n square, then what we do is we write the maximum dominating term as the complexity. So how do we write this? We write this as Tn is equal to O n square, because this is the dominating term. So how we find O n square and O n? We find in similar manner. So this is not a complete example. Now we'll talk about a complete example to analyze using a RAM model. Now let us take one example. Here we have got an algorithm, and one step is executed after another. See here. Now how do we analyze this algorithm? Now first you should know that every primitive operation takes some cost, and how many times do this primitive operation operates? Time. Now we look at the primitive operations over here. Now what are the primitive operations? This is not a primitive operation, but this is a primitive operation. Therefore it takes what? It takes a constant time, let's say C1, And how many times this is executed? It is executed one time, right? Now the here for this for loop, now what it is also primitive operation, but there are many primitive operations within the for loop. But what is the time it takes? What is the cost it takes? It takes a constant cost, let's say C2. And how many times the loop is executed? As here you can see that I starts from 1 and I is less than equal to n, therefore it runs for n plus 1 time. Now we have ignored this for the primitive operation for this one is 1 and for this one is n, but for this one it is n plus 1, so we write the one which is higher or which one is maximum, that is n plus 1 time. But later we will ignore even this one also, it will be clear when we will be doing some examples. Now let us see here how many times this primitive operation operates. This operates, the cost is basically constant C3, and it operates for how many times? It runs for how many times? It runs for n time, right? Because the body runs for n times in the loop. Because I starts from 1 and I is less than equal to n. Now the return is also a primitive operation, therefore it takes some constant times C4. And how many times it runs? It runs for 1 time. Now what we finally do is we represent this as a mathematical function, that is, how do we represent? We represent this as a Tn, or total complexity is represented as a mathematical function Tn. And what we do, it takes constant time, how many time? 1 time it runs, therefore C1 plus we take some constant time C2, and how many time it runs? N plus 1 time. Then again this one C3, and how many time it runs? It runs for n time, and again plus C4, right? Now we see here which one is the dominating term. Here we ignore all the constant and we write the dominating term. Now here if you see, then n is the dominating term, right? So we write simply as O n, because the constant are ignored, and we write the dominating term. Suppose if it didn't have any dominating term, then the complexity would have been 0, 1, right? But it has some dominating term n, therefore the complexity is O n. Okay, now let us take another example. So this is an algorithm, and we have got two loops, that is we have got nested loop. Now how do we analyze this one? See here, we first cost, and there is time, how many time. Now this I is equal to 0, this is a primitive operation, therefore what is the cost? It is a constant cost, let's say C1. How many time it executes? It executes for 1 time. Now while I is less than or equal to n, now this is a here we are making a comparison, therefore this is a primitive operation. And how many time does this primitive operation executes? It executes for n plus 1 time, because I starts from 0 and I is less than or equal to n, therefore we make n plus 1 comparison. And what is the cost it takes? It takes a constant cost, that is C2. Now how many times does this primitive operation executes? Here it is inside this while loop, therefore it executes for n time, and it takes some constant time, let's say C3. Now how many times does this while loop executes? Now see here, j starts from 0 and j is less than or equal to n, therefore it runs for n plus 1 time, right? But it is inside this while loop, see. So there are n plus 1 comparison because of this while loop, as n, this is inside the body of this while loop, and the body of the first while loop executes for n time, therefore there are n plus 1 for this one into n comparison, because it is inside the first while loop first, right? Now how many times does this primitive operation executes, or this arithmetic operation executes? So this one takes some constant time C4, and this also takes some constant time, let us say C5. Now how many times does this one executes? This executes for n time, because it is inside this while loop, and this is also inside the whole body of this while loop, therefore it again executes for n into n time. Now how many times does this one execute? Similarly, it executes for, it takes some constant time c6 and it executes for n into n time is equal to n square is equal to n square. Now how many times does this operation, primitive operation executes? It executes for n time and it takes some constant time, so let's say c7, right, because it is inside this while loop only. Now what is the complexity? Now how do we write complexity? We define a mathematical function Tn. This is equal to how many? C1 plus C2n plus 1 plus C3n plus C4 n square plus n plus C5 n square plus C6 n square plus C7 n, right? Now how do we write the complexity? Now see here. Now we ignore the constant and we try to find the maximum dominating term in this function. Now which one is the maximum dominating term? See here, c4n square plus c4n. It gives c4n square plus c4n. Therefore, n square is the dominating term in this function, and here also we have n square. Therefore, the complexity is O(n) square. So it is as simple as that. Now I hope you have got some idea on finding the complexity of some algorithms. Like for example, if a code is given and you got something like this, Tn is equal to C1nq plus C2n square plus Cn. Then what is the complexity of this? It is O(n)q, right? Now if you have Tn is equal to, if you get something like this, C1 plus C2 plus C3 plus 100 n, then what is the complexity? Complexity would be O(n). So this will be clear on other examples. So here I end my analysis, my lecture on analysis using RAM. Now we'll be talking about asymptotic notation in other lecture. If you like the video, you can subscribe, and if you have any question, you can comment below.